do this. Perfection. Okay, so here we are, and I'm going to also do this so my computer stops talking. We're ready to roll. So today we are talking about eye anatomy from the perspective of an iridologist. That might sound like a strange thing because the eye is the eye is the eye, right? And if you studied eye anatomy, maybe in high school, or maybe you're in a field where you needed to know eye anatomy, you learned it a particular way. And I'm not saying that what you learned was wrong. I'm just simply saying that when we are looking at the eye as an iridologist, we're looking for different things than what you were taught to look for as an optometrist or an ophthalmologist or a registered nurse or any other kind of practitioner. So important though, and I'm seeing all kinds of friends join us on Instagram. So good to see you there, Jody and Lynn Cap and Misa and F.A. Poor. Good to see you. Thanks for being there. And so it's just really important as we do this that you understand that we have to have this different perspective about the eye and about eye anatomy in order to really understand iridology. You know, so many people think that iridology is just looking at the eye and looking at the way a fiber is sitting or looking at a color patch or whatever, but they don't understand why those things are the way they are and why we need to, and what they mean. And further to that, how they got there, or just all kinds of things. So we're going to look at iridology from a very different perspective. Oops, I misspoke there. Eye anatomy from a very different perspective. All right. So I'm inviting you as well to comment and ask questions as we go. I will, like I said, try to keep tabs on all of the different chat boxes and comments that come in. But I would love it if you would make comments as we go and ask questions. I love answering questions. So one of the things that we need to remember is that iridology photos are taken super close up. And because of that, one of the things that you need to know about the anatomy of the iris is that when we do photos that are super close up, we may actually lose facial markers in the image. We may not be able to see things like, where's the nose? Where's that inner canthus? Things like that. And so you need to know that if you are looking at an iris, you can figure out which eye it is, whether it's a left eye or a right eye, simply by knowing that the pupil is off center. So look closely at this. These pupils are not centered. And that's not because this person is unusual. It's not because this person has something weird going on. Nobody's pupils are in the exact center of the iris. They're always offset, and they are always closer to the nose than they are to the ear. So when you look at this iris and you see that this side of the iris is narrow, this side is much wider, the narrow side names the eye. Oops, we've just lost our Instagram feed. We are going to give them a second to reconnect so that they don't miss anything. This is very sad that it's dropped. It says it's reconnecting. All right, so I'll bet that in school you were taught to put the pupil in the very center of the eye, right? I'll bet you were. And as such, that would be incorrect, but we don't really take time to notice that this is the truth of the matter. I just need to end the Instagram, and I'm going to pop back in here really quickly, and hopefully it will let me do this. I just really dislike losing an audience, right? Okay, I'm gonna come back here. Oh my goodness, telephone, cooperate. Post, we're just gonna, and Instagram is gonna be kind of silly today. So for my Instagram people, oh my goodness, I'm so sorry. We've lost you, and you can't hear me saying this. I will have to re-record this for them. Okay, because I don't want to waste the time of people who are with us on the webinar either. And so as we look at this iris and as we understand that the pupil is off center, the narrow side is what names the eye. So if the narrow side is to the right of the pupil, it is a right eye. If the narrow side is to the left of the pupil, it is a left eye. All right, and so that's a really important thing for us to acknowledge. Then and I'm just going to try to get back into Instagram super quick here. All right, so that's the first thing you need to know about the anatomy of the eye, is that the pupil is off center. And of course, if you studied iridology at all, you know it's very important that we ascertain which is the right eye and which is the left eye. Because if we don't have that basic information, the entire analysis, well, not the entire analysis, but a good portion of the analysis is going to be incorrect. When we look at an iris, what we see, or when we look at an eye, sorry, what we see is the whole eyeball. This is a cross section of the eyeball. And so we've got the basic structures that we all learned in high school, right? We've got the optic nerve that goes right to the brain. We've got the sclera that becomes the cornea, that becomes the sclera again. And the sclera actually wraps around the optic nerve to protect it. We've got the anterior chamber, which is filled with fluid known as the aqueous humor. We have the iris, which is actually a muscle. We have the lens, which is filled with fluid. This is where cataracts form inside this if something is not quite right. And then we have the posterior chamber that is filled with vitreous humor. I always remember that aqueous starts with an A, vitreous starts with a V, aqueous comes before vitreous, so aqueous is at the front, vitreous is at the back. So when we understand all of this, then we need to know that the pupil is actually a hole, it's an opening, it's a gap, and it's the gap through which light enters. So far, nothing new, right? So far, nothing new. When we are looking at the eye, we want to then take this and look at it as a cross section. So let's pop into a cross section view of the eye. So we've turned it over, and I've turned this up because this is our setup for our next slide. We are going to be looking at this piece as a schematic drawing. So that is this piece. All right, and so what we've got happening here then is lots of stuff. So the pupil is sitting right here. The anterior border layer is the layer that we actually visibly, physically see in a person's eye. And the pigment, whether your eye is brown or hazel or blue, actually blue has very little pigment in it, sits just under this anterior border layer, just right in here. Behind the anterior border layer, we have this big, huge section. Well, it's actually microns thick, not big, huge. And this is where the bulk of the fiber structure of the iris resides. This is why in a blue eye that has very little pigment, so there's very little pigment sitting in this layer, we actually see the fiber structure. In a brown eye, which has a lot of pigment in it, sitting in this area, in the anterior border layer, it totally hides all the pigment in the iris. And if you've got a biliary eye, which would, in street language, would be a hazel eye, you have a little less pigment, and we can often see some of the fiber in that eye. So when we look at what is the difference between a blue eye and a brown eye, it really is, number one, the density of the pigment. That's it. This is the density of the pigment. Brown eyes are much more dense. And so again, heavy, heavy, dense layer of pigment in here that then hides the fiber structure. When we look at the stroma, as this area is called, this contains a lot of different tissue. Not only does it have the fiber structure that we call trabeculae, which it also has blood vessels. It also has individual muscle fibers, and it has nerves. So it's a very busy, very thin layer of tissue. We also have the posterior epithelium. Now, or the posterior membrane is another name for it. Now, I remember in junior high and in high school, so junior high, some of you might call middle school, it was grade 7, 7th grade if you're in the US. And then again in grade 10, we had to do an eye dissection. So I think one was a sheep eye and one was a cow eye. And I couldn't do the cutting. I'm a little squeamish, but once it was open, once my lab partner did the cutting, I could get in there and look and poke around and have some fun. Get a life, right? But what I noticed, and I had no idea the significance of this at the time, was that the back side of the iris was dark brown or black. And that is this 2-cell layer thick membrane called the posterior epithelium. In humans, it is black. Okay, and in most animals, it is also black or brown, very, very dark. And so this layer actually wraps around the inner edge right here of the iris. And these cells are very light sensitive. These are the cells that have the photoreceptors that tell the pupil, or tell the iris whether it's going to constrict to open up the pupil, or whether the iris is going to expand and close down the pupil based on the amount of light. So that's really, really cool stuff. The sphincter muscle is a muscle that wraps around, and we're going to look at some images that show that. And you can actually see where the sphincter muscle is positioned in many lymphatic eyes and many biliary eyes. And this is the dilator muscle. So the dilator muscle is the one that is responsible for opening up the aperture of the pupil, because when these muscles contract, it pulls on this inner edge. When these muscles in the sphincter, remember the sphincter muscle goes around and around and around the pupil. And so when these muscles contract, it closes down the pupil. Let's have a look at some of what this all looks like. So when we are looking at this image again, to get the feel of what we're looking at, can you see that right here, this tissue in here has a different texture, and actually in this eye, a slightly different color to the rest of the eye? This is showing us where that sphincter muscle is. So where it changes right here is the edge of the sphincter muscle. This is all sphincter muscle. Now, in this dark of an eye, again, what we see is the textural change of the sphincter muscle tissue, or the tissue that is sitting in front of the sphincter muscle, to the tissue that's in the rest of the eye. And in a darker biliary or hematogenic eye, a brown eye, sometimes that sphincter muscle appears a lighter color. Okay, so we also then want to look at levels, depths of shading. So in this little diagram, we've got things that are white, which are sitting up high on the surface. And then we go down into layers, depths of gray, all the way down to black. Now, when we are looking at an iris and we are seeing areas that are shaded, we know there is less fiber, these trabeculae, these fiber, there's less fiber in here, and we're looking into the depths of the fiber structure. So those fibers are stacked up like this in the eye. When we're seeing shaded areas, we've got an area where the fiber is separated, and we're looking right down in between. And if it's separated deeply enough, we actually see the posterior epithelium. Now, we don't recognize it necessarily that it is that when we're just doing photographs, but if we had a slit lamp microscope, we might actually see that, right? So we've got areas in this eye that are very dark, which tells us that there's fiber separation, and we're looking into the depths of the stroma. When we see contraction furrows like we've got here, now this is really interesting. Contraction furrows, and you see one right here in this diagram, This diagram isn't quite accurate, but contraction furrows follow the contours of the posterior epithelium. So when the pupil dilates and the iris is constricting and it's working itself into a smaller area, what happens is that some of the fiber tissues have to kink because things are being compressed. They don't telescope, they kink. It's like the wrinkles in the front of your thigh, you know, where your body connects to your leg and you sit down, and if you're wearing pants, you get wrinkles there. That's exactly what happens here, because you've got fabric or you've got fiber being compressed into a smaller area. And that is what creates these contraction furrows. They become permacreases. And so the darker and deeper these are, the deeper they are, but that is a reflection then of how large the pupil is. The bigger the pupil, the deeper the contraction furrows, because the more compressed the iris tissue is. Does that make sense? Is that making sense to you? Okay, so that's something that we need to recognize, is contraction furrows don't go away. They don't disappear. They don't heal. They aren't, when they get lighter, they're not healing. When they get lighter, it's because the pupil has gotten smaller. And now those fibers are being stretched out, so the dips and the kinks aren't as deep. Then we have things like this corneal arcus, which actually is not an iris marker. It's in the cornea. So in front of all of this, we're just going to pop back one slide, 2 slides. We have the cornea. And the cornea is what is absorbing the kinds of fats or metabolic byproducts of carbohydrate metabolism. And that's what creates the corneal arcus. Is this making sense? I promised you we'd look at the dilator and sphincter muscle. Now this is really an important thing too. So this is the entire iris. This is the white of the eye. And of course we've got the pupil. We've got 2 sets of muscles in the eye that control the aperture or the opening of the pupil. And as we mentioned, it's the cells from the posterior epithelium wrapping up around the inner edge of the iris, that's those cells that are light sensitive that trigger the muscles in either the sphincter muscle or the dilator muscle to do what they need to do. So when we look at the dilator muscle, it is anchored in to the sclera edge. And it is attached to this edge of the sphincter muscle. So when these dilator fibers, the dilator muscle fibers that are straight, contract, they do this. When they do this, when they ratchet in, something has to move. But this edge is anchored. So it's this edge that has to move. As this moves, of course, if these are contracting, so we're getting a shorter length here, that's going to pull on this. As that pulls on this, it's going to stretch these fibers, which are like this. It's going to make them stretch out like this, and that's going to open up that pupil. If, on the other hand, there is way too much light in the room and the cells from that posterior epithelium, that pupillary ruff, are being triggered to make things constrict, that is going to take this sphincter muscle, and the sphincter muscle is going to ratchet in on itself, and that's going to do this. Now the sphincter muscle is again attached to the dilator muscle right here. So as this gets smaller, as the sphincter muscle contracts and pulls in on itself, it's going to pull and stretch the dilator muscle fibers. Does that make sense? All right. Did you know that the iris itself has over 28,000 nerve endings? We don't know what most of them do. Yeah. Popping back to the dilator and the sphincter muscle, we need to remember that the sphincter muscle is under the control of the parasympathetic system. And so that's trying to bring the body back into balance. Whereas the dilator muscle is more about the sympathetic nervous system, helping you deal with fight or flight. So again, in here, we see very clearly an edge. Can you see this edge right here? This is the sphincter muscle, right? Everything else is dilator muscle. So, you know, when we're looking at an iris, we are looking for fibers in the eye, especially if it's a lymphatic eye or a biliary eye. We'll see fibers. We won't see the fibers in a hematogenic eye. And so the fibers have another name. You've heard me use it a few times today already, called trabeculae. These trabeculae are actually capillaries or capillaries, depending on where you live. But a capillary or a capillary is pink, right? Sometimes we do see them as pink in an eye, but most of the time, these trabeculae are coated with a collagen coating, and that's what makes them appear white in our eyes. We know that the circulation in these capillaries, anything moving towards the pupil, no, let me rephrase that because otherwise it's not going to make sense. Anything moving away from the edge of the iris towards this ring here that we would call the collarette is arterial flow. Anything moving back out to the edge is venous flow. When we come into the center of the eye, moving away from the edge of the iris, so this inner edge is arterial flow. Moving back towards that edge is venous flow. All right, does that all make sense? That we've got to have a flow of blood through the iris itself to nourish the iris. So important. We also know that this area is the nutritive zone. This correlates to how our body deals with food. And we've got what we call the inner limbus. We've got the outer limbus. And this is all the humeral and ciliary zone. The iris is, of course, the focus of the study of iridology, right? And as an iridologist, we are looking for fiber structure. We're looking for patterns in the fiber structure. We're looking for color, the base color of the iris. We're looking for little freckles of pigment or washes of pigment in the eye. And it's really important to remember that iridology is not a crystal ball, right? With iridology, we never do the iris analysis without having a conversation with the client. Because with constitutional iridology, we understand that the eye shows us inherent health potentials, not actual disease processes. So we never look at an eye and say, oh, you have a kidney problem. We look at an eye and say, your eyes suggest that there is the potential for a kidney issue. Is there a personal or a family history of anything kidney oriented? Right? Because again, the client may be doing everything perfectly. They may have the best diet, the best lifestyle, and they may not have the symptoms that their eyes could suggest that they should have because the person is doing things right. So the eyes are a blueprint. They show us what the person's body is capable of. But if our client has been paying attention and is smart and has learned what their body wants, truly wants to be healthy, that client can totally thwart the efforts of the body or slow down the efforts of the body to break down. So let's do a little bit of a case study here. That be okay with you? Case study? Yeah? So here we have a female, mid-30s. This is one eye. Can you tell which eye this is? What's your best guess? Which eye are we looking at? Is this a right eye or a left eye? Her pupils are pretty close to center, just saying. You guessing? Now she came to me with fertility issues. She'd been trying to get pregnant for the last couple of years. She had conceived once and had miscarried. So as we're looking at her eye, even though her eyes are brown, we see not actual fiber structure. We don't see the individual trabeculae reaching outward. What we see is what we call lacunae. So when I see lacunae placed like this, and when I see that she's got brown eyes, it suggests to me that there may be some inherent potentials for different areas of weakness and malfunctioning in her body. One of the things that I needed to ask her about was if she was aware at all, if she'd ever been tested for the MTHFR defect, because there is a series of markings in her eyes that makes me think that that might be a part of why she struggles with fertility. I also noticed with her eye that there's this haze. Now we saw a corneal arcus earlier, and this is the very, very early stages of a corneal arcus where all of the iris markings are inherent or genetic. The cornea is not. The cornea is what you do to yourself. And so that suggested to me that she might again have had a history of a bit of a liver enzyme issue that might have messed up how she handled her carbs. So I needed to ask her, and I did ask her, how's your diet? And how's your cholesterol? How are your triglycerides? And have you had episodes of craving carbohydrates? And she said, oh yeah, I used to eat a lot of carbs. And about a year ago, I totally rejigged my diet. I don't eat the refined carbs anymore. So that's great. Now it's really important to remember that when we're doing an iris analysis, we don't need to focus on every single marking and give our client information about every single marking. This client's goal is fertility, to be pregnant. My job is to look at her eyes, figure out which of these markings help me to understand why she's struggling with that, and to teach her about those markings and those markings only. Because giving her information about every marking in both of her eyes is going to be a serious overload. She's not going to absorb most of it, and it's probably just going to serve to frighten her. Better to deal with the case at hand. So with her, again, I reconfirmed that her diet changes were positive. She needed to do a few more. She'd done a great job, but there was room for improvement. From what I saw in her eyes, particularly with this, I knew I needed to do some liver support alongside that. I knew from the way all of these markings are sitting that I needed to protect her mineral level and make sure she was getting all of the minerals in a good balance. And so we needed to really work carefully to structure her food choices, and not that she had to eat certain foods every day, but more that she needed to eat certain categories of foods in certain quantities, like a certain amount of protein, a certain amount of low carb vegetables, a certain amount of certain kinds of fruit, a certain amount of water, so that she had leeway to make choices with her diet. And then we were able to craft the supplement program around that. So again, we only focus on relevant markings. And so that is so important that we do that. Now, I just want to touch on a tiny little bit of commercialism here. Now, we've had one person weigh in and say, this is a right eye. Now, admittedly, this pupil is very, very close to center. So I always keep a ruler on my desk. And I should have made this note earlier. This is 1 3/8 versus 1 1/4. This is actually a left iris. It is slightly narrower on the left side. All right, so I just wanted to take a moment to share with you a few details about the upcoming session of Confident Nutritionist, the Dynamic Iridology Assessment System that will be starting very soon. This is a system that I've created based on constitutional iridology. It's very true to constitutional iridology. And in this program, I teach constitutional iridology, but I teach it in a way to serve practitioners, to help herbalists, nutritionists, aromatherapists, anybody who works holistically with people, so that they can create client programs right in their client sessions, so that they can create very deep rapport with their client very quickly, so that their client can feel very, very heard right in that first appointment. And that client will know that you understand what their issues are and you understand what the roadmap is to help that client. And this is all about, again, helping holistic practitioners to be successful using constitutional iridology. So I'm not going to give you all the details of the program right here, right now, because that's not what you came here for today. I'm just simply going to invite you to join me on Thursday, August 27th at 5 p.m. Mountain Daylight Time for a webinar where I'm going to go through some ways to help you improve, is maybe a harsh way of putting it, some tips that can help you be more successful in your business even without iridology. But we'll also talk about iridology and what's involved in this course, how you will benefit, how your clients will benefit, how this is going to help you with your business. So you can hop on over to iridology.education/webinar, and at that you can register there for this webinar that's happening on Thursday, October 27th at 5 p.m. Again, there is that link. So as we look at iridology and we look at the anatomy of the eye is so important. And it's important that we understand things like the anterior border layer and the posterior epithelium, and how what we label as contraction furrows are formed, what it means when we see shading and shadows in an eye, because that is all about the structure or the anatomy of the eye. And this is why it's important for us to know anatomy from a slightly different angle, or maybe a radically different angle than, say, an eye doctor would work with it from. Thank you so much for being with me today. I hope you found this session informative and that you've maybe learned a little bit, if you already practice iridology, that will help you to be a better iridologist. And hopefully, and I invite you again to join me for the webinar on Thursday, October 27th at 5 p.m. to learn more about iridology and the upcoming certification preparation program, Confident Nutritionist, the Dynamic Iridology Assessment System. Look forward to seeing you then, and thank you for being with me. Bye for now.